Hello friends, I hope all of you doing good, and as we have already started a topic called simplification of a context-free grammar, to continue that topic, today we'll see a subtopic called how to eliminate unit productions from a context-free grammar, and thereafter we'll go across eliminating useless variables. Now to continue this topic, let's begin our discussion, that is with a simple example. So we'll elaborate first what the procedure is to eliminate your unit productions. So this is a stepwise process. So in this, today's we will be seeing eliminating unit productions from a context-free grammar. Now, as we have seen, when we try to eliminate null productions from a context-free grammar, we used to find out nullable variables. So in that context, if we try to take this as when we wanted to eliminate unit productions from a context-free grammar, then we need to find out A derivables. So it's a process where A is any non-terminal which exists within a context-free grammar. So let's just begin and check out the procedure to find out what do you mean by A derivables. Now, if you see the first step within this, if there is a production called A producing B is a production in your context-free grammar, then we say B is A derivables. So this is also called as a unit production. Now, what exactly unit production means is, see, in a particular grammar rule, your left-hand side should be composed of a single non-terminal, which is deriving on its right hand side a single non-terminal. I want only single non-terminal on the right hand side. So this approach is specified as a unit productions. And in the step one, if A is producing B, is it a production? Then we say this condition as B is A derivable. Okay. And check out the next one. Now condition number 2 is, now condition this case is, if C is A derivable, in this, now the condition is C is A derivable, and that if there is a production C derives B in a given context-free grammar such like this, and is a production in your P, and what the condition is, your B and A should not be same. So what it means, your B and A should not be same. So these two non-terminal should be different. Then we say B is A derivable. So condition is something like this. You have A deriving C, C deriving B in your production rules. So we say C is A derivable. And if we continue this process, what C is deriving inside, so again we come back and notice that this is again a unit production. If this is the case, we say that B also A derivable. This is similar to like A, if A equal to B and if B equal to C, we in a transitive form we say that A is equal to C also. So in this A derivables property, we include this pair which suggests C is A derivable from this production rule. And again, if C is deriving B, okay, and A and B both are not same, then A derivable includes this pair which we call it as B is also A derivable. Okay, this is rule number 2nd. Now what is the rule number 2nd is, so there is no other productions that are called as A derivables. So within these two categories only we can find out the derivables. So let's check out this with a simple grammar. Now this example is very clear. So this is a given grammar. Now what we wanted to find out, for all non-terminal, I need to find out the derivables. As derivables are X, Y, P, Q, A, B. So there, see this P is a capital P and this Q should have been a capital Q. By mistake it is written something like this, so just take a note of that. And now if I try to produce S derivables, So I look for this context-free grammar rule, which is saying S is producing R, left hand side is a single non-terminal, right hand side contains a single non-terminal R. So I can add this pair S comma R, saying that R is S derivables. So I need to continue this process for the next iteration. So R is producing, there is a unit production where R is producing X. So when S and X both are not same, so in that case, this second production I need to add in S derivables, saying that X is S derivable. Now again, I need to keep this track of this chain X to look for any unit production that we have. So in this case, I don't have any unit productions. So the process terminates here. But when you start with S producing R producing, there is one more unit productions in terms of Y is available in the context-free grammar. So in that case, S and Y both are not same. So we should add Y is S derivable with this context. Okay, and we keep to track of this Y again, where Y doesn't have any unit production in it. So this process is supposed to stop here itself, and we get this as derivables. Now what about R derivables? We look for this R and check what unit productions we have in it. So R is producing X, it is in the specified form. So this condition, step number one, we can, using this step number one, we can write this R derivables, X is derivable from R, we can say. And we keep track of X and the process terminates here. And one more term, R, if it is producing Y, so this is again one more production which exists. So this Y is again R derivable. So this derivables we need to add in this set. So R derivables, one more thing, this is how we add it. So Y is R derivables. So we have a unit production R producing Y. That is why this type or this condition comes in this set. Now what about X? For X, Y, P, Q, A, B, we won't have any unit productions. We can check X doesn't have any right hand, any of this production doesn't have any single non-terminal on the right hand side. This the same case for Y. P, the same. Q, it is all terminal symbols we have. So these X, Y, P, Q, A, B are derivables are considered to be null. Now this is the procedure to calculate derivable properties for any non-terminal which exists within your context-free grammar. Now check out the procedure. The procedure is, which is elimination for the unit productions from a context-free grammar. So up till whatever we discuss, this is we called as unit production. So what unit production stands for? Any non-terminal on the left hand side is exactly producing a single non-terminal on the right hand side. If this is the condition available in your productions, this condition is specified as a unit production. Now check out the procedure. What is the algorithm says, though this algorithm is proposed how to eliminate unit productions. So just keep track of, and we will just apply this algorithm on a given example. So given a context-free grammar G, so this particular grammar is given, supposed to be given with no null production. So this is very important. If you're trying to eliminate unit productions, you should receive a particular grammar free of null production. So it should not have any null production in it. If it does have a null productions, you need to remove null productions first and then apply the procedure for removal of unit productions. See, to construct, see, from this we wanted to construct a G1 where it's having its own V sigma and SP, having no unit productions as follows. So what our ultimate aim is, see, I need to, the given grammar should be free of unit productions. These productions should not be available. This kind of production should not be available. And while eliminating this, we should make sure that, see, this context-free grammar, if it is generating or accepting or generating all strings of a particular L, By removing unit productions from this given grammar, the resultant grammar G1 should generate all the strings of the a particular L which G was accepting. So what are the procedures here? So procedure is really simple. So step number 1 is initialize your P1, which is you're trying to generate a production rules which is free of unit productions. It has to be initialized with this P, whatever the productions that are been given which are free of null. That is important. Now condition number 2 is for each A belongs to V. So as far as you consider V is considered as all a non-terminal, it's a set of finite non-terminals which are available inside your context-free grammar. Now if you consider this, for every A which belongs to a non-terminal, find the set of A derivables. The way we did just now, we need to find out within P properties of A derivables for considering, keeping in mind all the non-terminal which exist within a given P. Now what the step number 3 is? Step number 3 is for every pair, this pair, what it says, B is A derivable, okay, such that B is A derivables, and every non-unit productions B alpha, considering this production, add the production A alpha to P1 if it is not present in your P1 production. So let's just understand what it means. Now consider this is a context-free grammar which is given, and this is free of null productions. And if I want trying to eliminate the unit productions from this, I need to find out the A derivables first. So this A derivables, it's simple. So A is directly producing B, so I can add this particular pair which is saying B is A derivable. Okay, I need to keep track of this B, and B is not having any unit production, so this A derivable set is complete here. Now what B stands for? So B is having no unit production, so I won't have any particular null. So this B derivables having null elements within this. Now what it means is, if the given P is something like this, if we remove this B which is specified as a which is specified as a unit productions, when you come back to generate a particular new context-free grammar free of unit productions, that context-free grammar should be able to generate all the strings. It should have been what it would have been possible for him with this unit production. Okay, so in that context, I wanted to eliminate this B, but I cannot eliminate this as it is. So what it means, whatever B is producing, that is B producing alpha, this alpha needs to be replaced against this unit production B. So I need to add, in the process of eliminating this B, instead of B, I need to produce in the newly generated context-free grammar whatever B is producing. Okay, so that we, in a general forms, so whatever language it is accepting, it should accept all the same language. Okay, so this is a simple process. What B is producing, just replace B whatever B is producing by. So I am replacing. Now in this process, if you look back, so this B is unreachable. Okay, and all useless symbols I need to be discarded from the context-free grammar. But this, so it's an exceptional case. We'll follow this with the next example. See, this is a given grammar and it has been asked to remove a unit production from this. So first, step number 2 is, so we initialize this P to P1 and then we'll try to find out the A derivables. So look for all the non-terminal which exist. I have S as a non-terminal, T as a non-terminal, F as a non-terminal in the given context-free grammar. Now in this, what S derivables are? So there is a unit production S producing T, which is a unit production exist. So with the context with this, I need to add a pair S comma T and it elaborates as T is S derivable. Okay, I need to keep track of this chain, whether T is producing any unit production. So it exists within a given context free grammar. So T is producing F. Okay, what F is? It's a unit production. So in that context, and S and F both are not same. So in that context, I need to add this second pair, which is saying F is also S derivables. So just keep track of whether F contains any particular non-terminal. If we won't found, the sequence has to be terminated there itself. So for S derivables, we have this two elements. Now what about T? So there is a single terminal. T is having a unique production F, and with the context of this, we'll add this pair T comma F, which says F is T derivable. Okay, and if we keep track of F, we won't find any unique production. So this T derivables has to be terminated there itself. This set is complete. So what about F is? So F doesn't have any unique production, so it contains null. It's a straightforward approach. Once you find out all the derivables for all the non-terminals which exist, now the procedure has come to eliminate this unit productions and rewrite this grammar something like this. If I take the first grammar, see I have two derivables. So whatever you see, instead of T, I need to replace whatever T is producing. So in that case, see T is producing T multiplied by F and this capital F. So in that context, see this S plus T remains as it is. Instead of T, in your S rule, I need to add what T is producing. So I'll consider this T multiplied by F should be added back into this production rule, and I'll solve it only once. So considering this case, wherever you find this F should be replaced by what F is generating with the rule. So in that case, instead of writing F, I'll directly replace these two properties. Whatever F is S derivable, if it is, whatever F is producing, it should be added back into the non-terminal S. So in this process, this null production we have eliminated from this context free grammar. Same condition is true for T. So if we observe what we need to replace in this, see in this production, we need to replace F by what F is producing directly. So instead of F, see this T multiplied by F kept it as it is, and instead of F, we'll writing back whatever F is producing. So these two grammar rules gets added into this non-terminal T. Now F derivables are nil. So we directly write whatever the previous grammar, it has to be reflected in your newly generated grammar, and this grammar is said to be free of unique productions. Now I hope all of you understood that how to eliminate a unique productions from a context free grammar. Thank you.